In this video I'm going to solve some equations that contain radical expressions. For this we have to solve and then to check the solution or solutions. Now example 1. The statement is the square root of 2x minus 5 equals 5. In order to solve an equation that contains radicals, what is important is that we need only one radical at one side of the equation. So let's leave, in this case we have on the left only one radical, and this is very good because now we are going to square both sides of the equation. Why? Because if I square a square root, then the radicand will go free, no more radicals. And also I must square the other side. So therefore I will have the radicand free. 2x minus 5 equals 25. And then I will add 5 to both sides, and now I have 2x equal to 30, and dividing by 2 both sides we have x equal to 15. Now I have to check. Is 15 a solution? And for this, let me write here, is 15 a solution? And now I have, let's write the original statement, 2x minus 5 equals 5. And I'm going to substitute x with 15. And I'm asking myself, if I substitute 15 for x, okay, are both sides equal? That means I want the left to be 5. So what I have 30 minus 5, which is 25. And yes, 5 is equal to 5. True. Therefore, 15 is a solution. So you just check this, you don't need to write. Example 2. I have 4x plus 2, the square root of 4x plus 2 equal to the square root of 3x plus 4. In this case, I have two radicals, each at one side of the equation, but I am interested for at least one side. Okay, and now I will square both sides. In order to remove the radical part. So now 4x plus 2 on the left and 3x plus 4 to the right. And now since x appears at both sides, I will remove 3x from the right to keep x on the left, and also to remove these 2 from the left. And what I have 1x equals to 2. Now let me check. Is 2 a solution? I need to write the original statement and then to substitute the variable with the given, with the found, what we found 2 for x. Now that I will substitute, I am asking myself, if I replace x with 2, the statement will be a true statement or a false one. I'm interested for the statement to be true, and if the statement is true, both sides are equal. So what I have 8 plus 2, 10, and 6 plus 4, 10. True. Therefore, 2 is a solution. Example 3. 4 square root of x plus 5 equal to x. Now, when I read the statement, I see on the left I have a radical, but it is not alone, so first I have to remove 5. So subtracting 5 from both sides. And this will give me 4 times the square root of x, which is equal to x minus 5. So they are not like terms, just rewrite them. Now I am ready to square both sides. So 4 squared is 16, and the square root of x squared is just x, equal to, let's say, let me use the quadratic form, the square of a binomial formula, a minus b squared, which is equal to a squared minus 2ab plus b squared. Or you can multiply x minus 5 twice. Okay? Sometimes the formula is better, but it doesn't matter. So we have 16x equal to x times x squared. Okay, and now the second term is the sum of the numbers. Negative 5 and negative 5 is negative 10x. And the last term is the product. Negative 5 times negative 5 is positive 25. So you can use factoring, you can use this formula. The same works on the same speed. Now, what I have here? So I have x squared, I have x's, and I have the constant. So the idea is to write all the terms at one side, and let's leave the left side equal to 0 in order to try factoring. If we cannot factor this, we can solve the equation by another method. So the first thing, I am removing 16 from the left to get a 0. And I'm writing 16x under the x's in order to combine. So now I have 0 on the left, I have x squared, and this is a sum, negative sum, keep the common sign, and add 26x plus 25. It is factorable because 25 is 25 times 1, both negative, will give us 26. So I have x minus 25 times x minus 1. Okay, so the next step is to leave each factor equal to 0. X minus 25 equal to 0, or x minus 1 equal to 0. And here x must be 25, and here 1. So we have two values for x. Now let's check both of them. Is 25 a solution? Is 1 a solution? For this I have to write the original statement. So I have 4 times x plus 5 equal x. 4 times the square root of x plus 5 equal x. Here instead of x I will write 25, and here I will write 1. So I have 4 times the square root of 25 plus 5. Is this equal to 25? Let's see, 4 times 5 plus 5, it is 20, plus 5, it is 25. Yes, this is 25, equals to 25, and this is true. This gives us the right to accept this as a solution. Now let's see what I have here. I have to replace x with 1. And for this I'm asking, is this statement true? Are both sides equal? Let's see. 4 times square root of 1 is 4, and 4 plus 5 is 9. And 9 is not equal to 1. This is false, which means reject. 1 is not a solution because both sides are not equal. So example 4. The square root of p plus 1 minus the square root of 2p equal to 1. Now, on the left I have two radicals, so in order to square both sides, it's better for me to leave just one of them. So let me remove this square root of 2p to the other side by adding both sides the square root of 2p. And now on the left I have the square root of p plus 1, and on the right I have 1 plus square root of 2p. Now I am ready to square both sides. And what I have here, I have just p plus 1. And on the right I have 1 square, which is 1, plus 2 times the product of 1 and 2p, which is just the square root of 2p, plus, let me write this, the other term squared, the square root of 2p squared. So I have here, let me rewrite again. So this one will go if you have exactly the same numbers to both sides. So these numbers are gone. We can simplify them. Because if you subtract 1 to both sides, you will get 0. Now, what I have p on the left, and I have 2 times the square root of 2p plus 2p. And now I will remove this 2p to the other side because still I have a radical, and I'm going to square again. So again, on the left I have left only with 2 square root of 2p, and here I have negative 2p, and here I have positive 1p. Okay, so this is negative p. And now I'm squaring both sides because I want to remove the radical. And on the right I have p squared. On the left I have p squared, and on the right I have 2 squared. Be careful. Since here is a multiplication, we have 2 factors. Both factors will be squared. So 2 squared is 4. And the square root of 2p is just 2p. Since I have a p squared and a p, I can remove this to the other side and to factor for p. So I have here negative 8. Negative 8p. Subtracting 8p to both sides. Okay, so again, 4 times 2 is 8, positive 8. And now for this reason I'm subtracting 8p to remove this and to get a 0 to this side. So I have p squared minus 8p. Factoring out p, open parenthesis, I am left with a p here minus 8 equal to 0. And now I have 2 factors, p and p minus 8, both of them will let them be 0. P equal to 0 or p minus 8 equal to 0, I have one solution here, and here the solution is p equal to 8. So I have two solutions to check. 0 is a solution, or 8 is a solution. So let me write now the original statement. The square root of p plus 1 minus the square root of 2p is equal to 1. Again, the square root of p plus 1 minus the square root of 2p equals 1. Instead of p here I will write 0. And for this I have to try 8. So if I substitute p with 0, I have to ask if the left side is 1. Let's see, I have 1 here, minus 2 times 0 is 0, and now I have 1 equals to 1, true. That's mean p equal to 0 is a solution. And now what I have here, I have 8 plus 1 minus the square root of 2 times 8 is 1. And now 8 plus 1 is 9, minus 2 times 8 is 16, and I have 3, minus the square root of 16 is 4, but 3 and negative 4 is negative 1, which are not the same values. Therefore, this is false for x equal to 8.